Hello everyone, welcome back. Today we are solving one of the most frequently asked Java coding interview questions, that is valid anagram. Given two strings, how do we determine whether they are anagrams? For example, listen and silent. This expected output is true because both words contain exactly the same character with the same frequency. In this video, we will understand the concept, explore three different approaches, compare their time complexity, optimize the solution, and finally discuss where this problem is used in real world projects. Before writing code, let's first understand what an anagram actually means. Two strings are called anagrams if they contain the same character with the same frequency. The order of the character does not matter. Take the word listen. If we sort its character, we get this. Now sort the word silent. Again, we get this. Since both sorted strings are identical, they are valid anagrams. Another example is race and care, but cat and rat are not anagrams because their characters are different. In an interview, never jump directly into coding. Instead, discuss multiple approaches. The first approach is comparing every character one by one using nested loops. The second approach is converting both strings into character array, sorting them and comparing the result. Finally, the optimized solutions uses character frequency counting or a hash map. Explaining all approaches shows interviews that you understand the problem deeply rather than simply memorized code. Let's start with the brute force solution. Here every character in the first string is compared with characters in the second string. This requires multiple nested comparisons. Although this method is easy to think about, it becomes extremely slow as this input size increases. Its time complexity is O of n squared, making it unsuitable for production applications. This is usually the first idea beginners think of, but experienced engineers immediately look for something better. A much better approach is sorting both strings. First, convert both strings into character arrays. Next, sort each array using array.sort method. Finally, compare the sorted arrays using array.equals method. If both arrays match, the strings are anagram. The solution is clean, easy to explain, and commonly accepted during coding interviews. Now let's look at the optimized solution. Instead of sorting, we count the frequency of every character. Create an integer array of size 26 for lowercase English letters. Increase the count while scanning the first string. Decrease the count while scanning the second string. Finally, verify that every value in the frequency array becomes 0. If every count returns to 0, both strings contain exactly the same character. Many candidates ask where this logic is actually used in software projects. These are the examples. In banking, similar validation techniques help detect duplicate or recorded transactions references. In e-commerce, search systems use a character comparison for spelling and keyword matching. These for healthcare and logistics as well. This important point is not that companies solve anagram directly, but that character frequency algorithms appear in many real-world validations problems. Let's finish with some interview questions you should be ready for. These are the interview questions, and if you found this useful, don't forget to like this video, subscribe to the channel, and let me know in the comments how you would solve this problem without using array.sort method. I will see you in the next Java coding interview question.